All right, boys and girls, we are going to work on MathBoxes 1-9 on page 20 in your workbook. Remember, you have to do that page first before you watch this video. So if you did not do all of the problems on page 20, please stop the video, do the problems first, and then watch the video to go over them and check your work and make sure that you understand. Okay, let's look at number 1. Number 1 is a bar graph problem. Let's see if I can get my screen to move here a little bit. Okay, so this is a bar graph. And remember, when you're looking at a bar graph, the very first thing you should do is look at the title. Look to see what this bar graph is even about. This bar graph is about children's lesson choices. If you're like, well, what do they mean, children's lesson choices? Look down here. Remember, we talked about all these words down here at the bottom. These are going to be what this bar graph is about. So the lesson choices are swimming, music, art, and juggling. And then look over here. Over here is our number of children. So remember, look at that scale. We talked the other day when we were working on bar graphs about the scale. Let's look and see what that scale is counting by. Okay, my orientation's off a little bit on my board. All right, look at that scale. 0, 2, 4, 6, 8, 10, 12. What is that scale counting by? We're counting by twos, right? So each of these spaces on the bar graph will be worth 2. So as you're answering questions, you got to remember that. You got to pay attention to your scale, and you got to understand what you're looking at. So the very first question said, did more children like music or swimming? This is a very simple question with bar graphs. We're comparing music and swimming. So all I got to do is look at these two bars. Now, it didn't ask me how many children like music or swimming. It just asked me which one did the children like more, music or swimming? So you're just simply looking for the taller bar. So of course, music is your answer. Okay. Now the second question gets into the nitty-gritty a little bit more, and it says, how many more children chose music than art? When you get that question, how many more, now you're comparing. You're finding the difference between the two. So I am looking now at music and art, and it wants to know how many more children chose music than art. So 12 children chose music and 6 children chose art. So I'm finding the difference. Now one way I can find the difference is to subtract. So 12 of them liked music, subtract the 6 that liked art, and 12 minus 6 is 6. Or I can look at it this way. I can look at those two bars and I can count the spaces that aren't shaded in for music, and so I can tell that 2, 4, 6 more kids like music than art. I can count those spaces that aren't shaded in to find the difference. Okay, so how many more children chose music than art? Your answer is 6. Okay, moving on to number 2. All right, this question here is a question about elapsed time. It said that Cindy leaves her house at 9 o'clock a.m. She arrives at her grandmother's house at 11 o'clock a.m. It wants to know how long does it take to get to her grandmother's house. You can use your toolkit clock or draw an open number line to help. Now for some of you, this just might be something that you can just kind of do in your head. But even if you can do it in your head, you can show me the steps that your brain took on an open number line. So if she leaves her house at 9 o'clock and gets to grandma's at 11 o'clock, now I can jump across this timeline, and so you can even just show me how your brain jumped. Now notice, both of them end with 00, 0. Did the minutes change? No, we're going from 9 o'clock to 11 o'clock. So the minutes aren't going to change at all. The only thing that changes are the hours. We're going from 9, the hour of 9, to the hour of 11. So we're just going to skip count by hours. Well, how many hours would go from 9 to 11? And that would be 2 hours. Okay, so your answer here is 2 hours. You can abbreviate it this way, or you can just abbreviate it with an H, or you can spell out the word hours. I'm okay with either abbreviation. All right, moving on to the next problem. Number 3 says to estimate the length of this line segment. Now, estimate means you don't have to get out a tool and measure it exactly. When you're estimating, you're just kind of guessing. So when you look at this line segment, about how long do you think it is? Now, I'm going to use my fingers to help me out. And I wish I had a picture. I'm going to kind of draw a picture of my hands here and see if I can. This is going to be a pretty weird picture on a smartboard. There's my fingernail up here. Okay, boys and girls, there's a knuckle. Right below my fingernail is a knuckle. And then when I bend my finger, I have another big knuckle kind of midway of my finger. When I bend my finger, that knuckle to knuckle is about 1 inch. So right now, no matter where you're at, I don't care if you're sitting in the classroom or you're sitting at home doing this work, I want you to bend your finger, take your pointer finger, bend your finger, and I want you to look at that space right past your fingernail at that knuckle to the big knuckle that's bent in half there. That space right there is about 1 inch. So when I lay my finger down from knuckle to knuckle on that line segment, it looks to me like it's about 1 inch. Okay, so that is going to be my estimate. Then I'm going to get a tool to check my estimated length. Okay, when I'm getting out a tool, what am I going to need to measure length? I need a ruler, right? Make sure you have a ruler. Make sure it's on the side that's measuring in inches and not centimeters. And when you lay that ruler down on that line segment, you're going to find that it is exactly 1 inch. Okay, so when you're measuring it with the tool, it is 1 inch. All right, moving on to number 4. I want you to fill in the unit and solve. All right, remember we talked about that equal symbol being kind of like a balance scale. One side over here has to equal or be the same as that over there. Okay, but they gave us a lot of subtraction in this one, which makes life a lot harder. Okay, here's what I want to bring to your attention. I'm going to write a problem over here. Let me give myself a blank sheet of paper. I'm going to do a problem, okay? All right, I'm going to do just a simple problem. 5 minus 2 equals 3, okay? Or 5 minus 3 equals 2. When I have a subtraction problem, I want you to notice which one of these numbers is the biggest number. Well, the 5, right? The biggest number in a subtraction problem is always going to be right before the subtraction symbol. Even if I write it really funny like this and put 3 equals 5 minus 2, it looks different when I write it that way, but it's still saying the same thing. You see my subtraction symbol right here? The number right in front of that subtraction symbol is the biggest number in this problem, because you're taking away from that big number. You can take the other two numbers and add them together. So 2 plus 3 equals that 5. Over here, those numbers are spread apart, but still 3 and 2 equals 5. In a subtraction problem, the biggest number is going to be right before the subtraction symbol. So let's go back to the problems. If I can get my board to cooperate here. All right, look, here's the subtraction symbol. That means this blank is going to be the biggest number, okay? Well, guess how I get that big number? I add the other two numbers together. What is 9 plus 6? You can pause it if you want and figure that out. 9 plus 6 is 15. So guess what? Over here is 9. I have to make this side equal 9. 15 minus 6, if you want to check it, 15 minus 6 is 9. Okay, so the answer to the first one is 15. All right, let's look at the second problem. All right, another subtraction one. Here's the subtraction symbol. This is the biggest number, okay? So that means these other two numbers I'm going to add together to equal that 16. So 8 plus what equals 16? 8 plus 8 equals 16. So 16 minus 8 equals 8. All right, looking at the next problem. Here's my subtraction symbol, and look at my number in front of it. That's going to be the biggest number in this problem. So my biggest number is 11. take the other two numbers and add them together. 4 plus what is 11? So put up 4 fingers. Now, how many more fingers do you have to put up to get to 11? Okay, 4 plus 7 equals 11. So 11 minus 4 equals 7. All right, looking at my next problem. Here's the number 12 right in front of my subtraction symbol. What did I tell you? The number right in front of the subtraction symbol is your biggest number. So take the other two numbers and add them together. 5 plus what equals 12? Figure out, what do you need to add to 5 to get to 12? Well, 5, 6, 7, 8, 9, 10, 11, 12. How many more did I need? 1, 2, 3, 4, 5, 6, 7, right? 12 minus 7 equals 5. Okay? Boys and girls, I do not like to do subtraction. So if I can turn it into addition, I'm going to do that. Right? Here's another subtraction problem. Here's my symbol. This number is going to be the biggest number in the problem. So how am I going to get that big number? Add the other two numbers together. 9 plus 9 equals what? 18. So 18 minus 9 equals 9. Okay, this is just fact families, guys, using addition to help you solve subtraction. All right, and then finally, the last problem, explain what tool you used and how you used it to check your estimated length in problem 3. Well, I used my finger, so I'm going to say I used my finger, and I'm going to say from my knuckle to knuckle is about, and remember, about, everybody has different size fingers, but it's about 1 inch. That's what I use to help me to know about what an inch is. All right, guys, that is it for lesson 1-9.